Okay. Well, thank you for that fabulous introduction. I'm delighted to have the opportunity to come here. I am from Iowa State University. I'm also the director of the ACS Exams Institute, so I am perhaps the only person in this room who your students feel is more evil than you, because I'm responsible for the exams that many of you have them take when they come into graduate school in particular. So my Twitter handle and the hashtag I've been using to tweet about all of this today is up there in case you're looking at that. I have been getting responses back from people around the world, so Denmark has been chiming in on what we've been talking about here. So for those of you who dislike, I pointed in the general direction of the audience, but there are people who are wondering why would anybody tweet about something like this, so that's why I brought that up. So what's the challenge? So you know, sitting through a half a day of this this meeting already, it's an extraordinary group of people to bring together like this, because the idea flux is enormous, right? And that's a pretty important component of why you would try to bring this group of people together, is because that's probably the normal state of this cadre of folks. If you could put them in a room about anything, and the idea flux would be very high. So what is it that's going to make it so that anything that might generate from this meeting doesn't get very far from here, right? Susan has kind of mentioned that in her talk, that there's this big issue about propagating and replicating education reform efforts. And what I wanted to try to talk about a little bit is some of that. So why is it a challenge? What can be done to kind of make chemistry education reform efforts more widely adopted, and what are some of those barriers that tend to make it localized, and how do we address those? And I would argue that there's a very, very important fundamental tension that we all encounter as we go along whenever we try to do any kind of change in the classroom, and that is that teaching is a fundamentally personal thing. Okay, when I'm in my classroom, and the students fail at something I think I've done a really nice job explaining, that does not feel good at all. And we've all experienced that, right? Because it feels like we must have done something wrong that our students can't figure out what the pKa, which proton is there at this pKa, right? And we know for a fact they can't do that, right? You give them a pH, and they can't, and pKa's of all these protons, and they don't know which ones are on and which ones are off, regardless of how much instruction you've given them, okay? So teaching is personal, but at the same time, it's a corporate enterprise. That's the only reason you can explain why we're all here, okay? It's because it's a corporate enterprise. Other people care how we do. It's personal to us, but other people care what we do, and some of those people are our bosses, okay? And so that's a really important issue, so that when we start doing things that are kind of personal to us, and other people care, that's when it gets into an issue. And if you've had the misfortune of trying to launch a textbook in a major market, that's where you really found the difference between personal and corporate interest, right? Because anybody who's started from scratch to write a new textbook in, say, general chemistry, realizes by the time the textbook comes out and it has a cover on it like this, that it doesn't look like the textbook idea you had, okay? That to get through the 20 or so reviews that it takes before you get a textbook out by 20 persnickety people, okay, you've had to compromise a lot, all right? Something that doesn't happen naturally in Washington, D.C. happens when you write a textbook, okay? You have to compromise, okay? So the premise that we have to think about as we think about education reform is that while we're all interested in a very broad sense, to propagate it, we have to appeal to that personal component of every person who we want to try to do what we think is interesting, right? So we can't propagate it until the person who we're talking with is convinced that it's an okay thing to do. So that's the key. We have to manage that personal-corporate divide as best as we possibly can. And I argue that enthusiasm, which we almost always have, and I'll say this in a moment, for our own innovation, can get us in the door, can't make the sale. All right, and so that's where the idea distinguishing between enthusiasm and evidence is the important key that we have to think of as academics when we do this kind of thing. And there are resources available to us for this. And I'm not going to, in the relatively brief period of time, although I'm cognizant of the fact, and I've been reminded of the fact that I was given extra time because I was going to talk about a few of these things, there are things that you can look into. So, and several of them are from the NRC. So how people learn has been around for a very long time. And it includes a lot of the things that you may have heard and maybe didn't really quite have a great handle on that Susan talked about in terms of what we know about learning. Okay, so things like prior knowledge is an important component of how people learn, right? Our students don't come to us with no knowledge at all. They come to us knowing that molecules get bigger when they get heated up, right? That's what they know, okay? So we have to dissuade them of that while we teach them that, no, they just move faster. They don't need to get any bigger. Okay, so that's part of how people learn is built into things. Things like metacognition, which is can they think about what they know? Okay, can they think about how to solve problems? So those are the types of things that are out there. The PCAST report, as we heard earlier, also the Engage to Excel, also kind of lists off some of these things. So there's stuff out there. I'm going to spend a fair amount of time on this report. Simply, I skipped over this. There's hidden slides, but I skipped over it for time's sake. So I could get to this one because it's newer and to a certain extent perhaps more interesting. So the Board on Science Education within the NRC has fairly recently come out with the Discipline-Based Education Research Report. And so I'll spend a little bit of time kind of giving you a handle on what's in that report and why it might be helpful if you're thinking about education reform. Then a little bit about innovation diffusion in the context of chemistry education. Many of you think a lot about innovation diffusion in the context of products, okay, or ideas in chemistry or in science, but I'm going to try to look at that from the ideas of education. And because I'm from the Exams Institute, I will note that assessment is almost certainly going to be part of this. And so I will talk about some of our own research just briefly at the end as an example of things. And because it was mentioned earlier, I think it was Joel mentioned it, I will tell you that ACS exams is part of the solution if you want it to be. So SJU CSB, so this is St. John's, St. Benedict's, has on our new exam, electronic exam delivery product, custom-made exams for their new, very strange way of doing the first 2 years of things. So we have worked with them to deliver the kinds of assessment materials they need. Okay, so we're out there ready to do that, and that was based on an electronic platform. The NSF program officers are nodding their heads back there. Yes, NSF helped support that development of that product. Okay, so here's the DBER report. I didn't get a high-resolution image, I'm afraid. I just took this one off the web. Chemistry has been established, and Susan talked a little bit about the idea that the initiatives helped boost this young field, and it's a fairly robust field of people who spend most of their scholarly pursuit as chemistry education researchers. All right, this is not the same thing as scholarship of teaching and learning where you're making careful measurements of what you're doing in your classrooms. They're focusing on how people learn chemistry. They have deep knowledge of chemistry and some knowledge, in many cases very deep knowledge of either things like measurement, which is where my specialty is, or things like cognitive science. Okay, so chemistry education research, or CER, was among the disciplines that was part of that contributed to the Bose DBER report. And so there's anecdotes throughout this resource. There's a copy of it out on the table out here, and like all of these reports, if you can get the PDF of it online. Excuse me. So I mentioned that how people learn that focus on prior knowledge can be a really important component. So that's one of the things that they've noted in the DBER report from Bose. So there's no question that chemistry has some unusual constraints on it with respect to prior knowledge. Maybe some of you are familiar with, and some of you have mentioned hearing Carl Wieman talk last year about this time, that physics has been demonstrating these things for a long time, right? So there's this force concept inventory that students, doesn't matter how much you teach them, the mathematics of it, when the Volkswagen hits the garbage truck it has a bigger force on the Volkswagen than the Volkswagen does on the garbage truck. That's a misconception that students have in physics, and it's hard to beat that back. We have it in chemistry as well, And the thing about this is that in chemistry, the problem is that it's oftentimes much more abstract. So the particulate nature of matter, where we tend to think, right, how do atoms do what they're doing, how do molecules do what they're doing, is actually a source of significant misunderstanding for the students who come in the door. Okay, and part of it is caused by us. All right, so Melanie Cooper, who's the lead author on this paper, calls it, I think it's didascogenic. Right, didascogenic, I think is what she uses, right, that the teaching causes it. All right, teaching can cause the problem. And so an example of that is that it's the representations that we use. And many of you in the room have taught Gen Chem at some point in time, and you can probably attest to the fact that in general chemistry, Lewis dot structures stop at 6 atoms, or 7 if you do SF6. Okay? Never do they have carbons and carbons touching one another. Right? So when students get to organic chemistry, we shouldn't be shocked that they start to fail precipitously when we ask them to put 2 carbons in the molecule. Because we've taught them over and over again how to do it with just 1 central atom. And so they have built very efficient schemas in their head on how to do it with 1 central atom and no schemas at all for how to do it with 2. Okay? So that's a study about how students learn that's doable if you're careful about how you go about doing things. Another thing that we often hear about is math preparation, and it's certainly true, but scale is a huge issue as well. Students can't get it through their head how many times molecules manage to collide. Okay? That's just an enormous number, and they can't deal with it. So they have a very difficult time with scale. And my colleague in the Exams Institute, Krista Murphy, who's at the University of Wisconsin-Milwaukee and is the associate director, has done some really nice research that suggests that scale literacy is actually a better predictor of whether students are going to succeed in general chemistry than math or any other kind of predictor that you can imagine. Right? So if students can get their minds around how small molecules are, and how many there are in a macroscopic sample, if they can do that, they're going to be better than if they can do calculus. Okay, essentially is what that's saying in terms of general chemistry. And so these are the kinds of things that you can start to find out if you start to ask the questions in the right way. And so that's part of what the DBER report says. I've gone over a little bit in terms of how much time I wanted to dedicate to that. So the other thing, one of the other really important things the DBER does, and I'm going to launch from here for the rest of things, is it talks about how to take education research results and impact teaching or affect teaching. Okay, we're just going through page proofs, so I can't say impact. It's not a real verb, apparently, unless you're talking about teeth in your jaw. That's what my editors tell me. It's effect, it's not impact. So, so the basic idea is it's hard to turn basic research on education into interventions, and it's hard to turn local changes into larger scale change. There's a report. It's an NRC-based individual cure, and so there's a credit down there at the bottom to this. NSF has been funding professional development activities for a long time associated with these things. They have a little bit of the preaching to the choir effect because the only people who come are people who've already decided they want to go. All right, so they must have had some reason to think that they should do something more about their teaching. And there's certainly, we've heard about this before, institutional factors are clearly an issue that one has to think about. So I want to talk a little bit more about the diffusion of educational innovation. All right, the good news about this is that this group thinks about innovation diffusion a lot. Right, as scientists, we think about how are we going to make sure that people understand what our science is, or how are we going to make sure that our company's products are keeping ahead of the competition or keeping ahead of the curve. When it comes to education, however, the roles of enthusiasm and evidence have to be delineated. That enthusiasm is only going to get you so far. And you have to think about how you're going to communicate beyond just your enthusiasm. Okay, it's hard for me to imagine anybody in the room would come up here. We couldn't have found anybody to invite who would come in here and say, well, I spent the last 4 years trying to, fix Gen Chem. Yeah, and it's better now, but, you wouldn't really want to do that, right? It's inconceivable. Nobody would spend 4 years doing that. They're all going to be more like me. They're going to be bouncing around saying, this is great stuff. You've got to do this, okay? So I can, however, imagine all kinds of you in the room who's sitting there right now. This guy's all wacko. I'm never going to do anything that he's dead, right? Right, you're going to have, it's much easier to be interested and enthusiastic about your stuff. It's hard to convince somebody else to be enthusiastic about your stuff, and that's the key piece. Okay, so by the book, the book is the Bible, if you will, of this, is that the classic text, if you will, is Diffusion of Innovation. It's by Everett Rogers. We know this is a spectacular book because Everett Rogers is an Iowa State alumnus. His first book was written in 1965, so it tells you he was an Iowa State alumnus before I was alive. So it's a long time. We've been producing great things at Iowa State for a long time, is the nature of that story. There are several key ideas. We're going to only focus on a couple of them. The basic definition is this: diffusion of anything, but we're going to talk about education. Diffusion is a process in which innovation, so we're going to talk about that, is communicated. We've heard a lot about communication, but it's not just standing up. It's about how are we going to argue, right? Who's going to sit next to me? Well, nobody's going to sit next to me on the bus on the way back. I know that, but how am I going to convince somebody at that point? And it's going to take time, as has been mentioned earlier, and there's this weird social system in which we do all this stuff, okay? So the key innovation characteristics, many of these things you've seen in the way that they've been, the things that we've been hearing about, and the stuff that's coming after me, we're going to have these, they're going to be replete with a lot of these characteristics. That's why they're here. All right, the key thing is that the listener who's listening for evidence, that is somebody who's maybe deciding, I'll do this, is going to care about these things. If they're not provided, when you talk about it or when you communicate, they're going to make up their own, right? If you don't tell them about its relative advantage, they're going to make up their own, and I'm betting they're going to say their current way is better, right? The relative advantage is how I do it now, right? So you have to communicate these things as you go in. So relative advantage, is it better? Compatibility, is the idea not all that different from what I do now, okay? That's important. Nobody's going to want to do it if they feel like they really have to change everything they ever knew about themselves. Teaching is personal. The idea is not too complex that I can't even imagine doing it, right? That's an issue. So let's say you want to teach Gen Chem starting from the Schrödinger equation, okay? People have done that, all right? But your average organic chemist is probably going to balk at that as the way of organizing thinking about general chemistry, okay? It's not going to help them when their students get to organic, for example, in many cases. Trialability, can I do this in baby steps? Okay, can I do it at my own speed? That's an important idea. And observability, I have to be able to see how it's going as I'm doing this, right? So you've got to tell them how to observe what they're doing, okay? And so the other component then is that if I'm thinking about the person, the characteristics of the person, okay, at the risk of sounding unduly mercantile, what are we going to need to understand about our targeted customer? And right now, we don't want to think about our students as customers. We certainly don't want to think about our colleagues as customers, but that's the metaphor I'm going to need here. And so the decisions that your colleagues are going to use when they decide whether or not to use your innovation are basically this. They have to somehow, there's a stage where they get to know about the innovation. For many of us, we're getting that here today. We're going to hear some great ideas, okay? There's some time for, there's the persuasiveness of the innovation. Is it better for me or not? And then there's going to be a time where they're deciding whether to do it or not do it, and they're going to implement it, and then they're going to confirm whether to keep doing it or not, right? So those are the stages, and if we don't get to the confirmation where they say yes, that means the propagation of the education reform has not happened, right? So if you don't do all 5 stages, you lost that game, okay? I will argue that these 2 pieces, enthusiasm helps a lot, right? And that's normal and natural. So when you tell people something enthusiastically, they're at least going to hopefully, in many cases, stay awake, okay? And that's, the enthusiasm can be persuasive. By contrast, for them to decide to adopt or to reject that idea, they're going to look at the evidence. They're not going to just say, well, yeah, that person likes doing it, they're good at doing it, that means it's going to be good for me. They're going to want some evidence. And then, if you think about that, the evidence needs to be, okay, the same kind of thing that they're going to be able to get for themselves, right? So the evidence you provide about your educational evidence, innovation needs to be in a format of some sort that they can use to assess their own implementation, right? If it's too hard to do, if your evidence is too ethereal, or and some of you, I'm sure, will, you know, we kind of heard this earlier with the low-performing MIT students, right? So the folks from MIT all the time, I'm sure, every time they talk about an innovation, they say, yeah, well, that's MIT students, right? You hear it all the time. Berkeley students, you know, we're going to hear from Angie later. That's a common thing. So people are going to want something that they can use in their environment to assess their students, right? Not just what you've done. Okay. What about this weird social system that was in there? I'm going through that definition again. The first thing is it's not exchangeable. We are who we are, and we hang out with who we hang out. Okay, and that's so it's not exchangeable, and it's in fact not particularly amenable because university faculty are susceptible to enthusiastic skepticism. There's no question that they're just going to be skeptical. They're going to jump in with their skepticism at every opportunity. And it's also characterized by how people learn, right? So I mentioned, I mentioned that from respect to the Deber report earlier, right? How people learn is cast in those cases in terms of novice science students. But if you're a novice in terms of how do you know whether your educational innovation is working, you're going to use many of the same strategies, right? You're learning that type of thing. So it's characterized by that. So one of the things in the Deber report that I didn't mention earlier, because I knew I was going to mention it here, is that students actually have a very difficult time, broadly speaking, some students obviously don't, have a very difficult time distinguishing between data and evidence, right? So your students, you can tell them, you need to tell me which one of these things is a pure compound, right? They can go into the laboratory probably and come up with some sort of data that tells, so that they believe this is the more pure compound that I've made, or whatever, okay? But they won't necessarily be able to tell you why. That is, they won't be able to marshal that data into evidence as to why it's better or more pure. And that's where our colleagues and many of us have trouble. And certainly, the difference between data and evidence is an important component. And again, the DBER report points this out to us as well. Okay, so our colleagues may or may not know how to decide about the efficacy of this, but they will probably believe they know. Okay, that's the other really challenging component of this. All right, so they may or may not, but they certainly believe. Okay, one of the things that we talk about often is this whole idea of private empiricism. Right, so it's certainly true that those of us who've taught for a long time can get a feel for how our students are doing, right? We can just tell even from the body language in the classroom if you've been doing this for as long as many of us have. But that private empiricism is not data. It's at best an anecdote, and an anecdote is not data. It's at best a datum, all right? And it's usually not even that. Okay, so anecdotes it's very hard to marshal enough anecdotes to get impressive evidence, right? It's very hard to do that. Although Project Kaleidoscope tries to do that and probably has some success. So assessment, how are we going to get to that? And you knew this was coming, right? Because it's the ACS exam guy, and he's going to have to talk about assessment. Okay, but I'm going to try to do this in a way that because I am steeped in chemistry education research. I have most of my group are chemistry education research students. My computational chemistry group is fairly small. So how is it that we go about getting data that we want, that we can marshal into arguments that represent evidence, okay, so that we can use the assessment that we have or the evaluation that we have more effectively when we make those arguments, right? So that's the kind of the last goal here. So and I'm going to do that, my theme is going to be what do chemistry faculty members know about assessment, all right? So I'm actually going to switch into a description of a small portion of my research rather than talking in these kind of platitudes about books that were first written in 1965. Okay, so to tell you about this, the Exams Institute, as many of you in the room know, writes, we have groups of people who get together and write nationally standardized exams in all kinds of fields of chemistry. The question is, what if people don't know what we do or don't know much about us, how can we reach out to them to help them with things like, for example, the CPT requirements now say you should tell us some sort of outcome measurement, and many departments said, well, we don't know how to do that, and so the Exams Institute felt like we needed to try to provide resources in that regard, but we didn't really know where the community was, so we decided to do a needs assessment survey. This was funded by the National Science Foundation. To do that, we developed the survey with several focus groups, so it's a needs assessment, so you need to know where the top bar is, and you need to know where the people are, right? So you have to kind of focus group at both ends. Then we did pilot studies, pilot surveys with small numbers of people, and this process took about 8 months for us to do with dedicated postdoc personnel on that. Okay, and so it's not like, oh my gosh, I'm starting to teach on Tuesday, I better put together a survey. Right? That's occasionally going to get you something you might be able to marshal into evidence, but it's normally not the best way to try to go about getting something that's you're going to be able to marshal into evidence, right? So the idea is that you have to think about your assessment over time and go through all these replications, as was kind of noted before. So we had a whole bunch of question categories. I'm not going to go. We were interested in program assessment and professional development and so forth. We had a bunch of demographics. I'm going to talk about the familiarity that faculty have with assessment terminology and how we went about doing that in a way that we think provides compelling evidence for where the community really is, okay? Our survey population, yeah, so the 67% thing, yeah, that's just out of the world for us. We don't even begin. So our inducement was, about 20 people won iPads from us for this, and so that we did okay. We got about 10% respond rate, which is kind of normal. Our population included tenure track, non-tenure track professors and instructors in the U.S. Demographically, they came from all over 2-year, 4-year, and doctoral colleges, and from all of the disciplines. Some people didn't tell us what they do in terms of the demographics. So at the very end of the survey, what we decided to do after several focus groups where we started to talk with people about what terms do you even know about assessment and which terms do you think kind of sound like jargon and just turn you off completely, we came up with this list, all right? And this list could be argued, right? Because there are enthusiastic skeptics everywhere, and in the education research community, there are enthusiastic skeptics who will say these were a crummy set of terms for us to choose, okay? And we've heard that from reviewers in some of the papers, but this is what we have. So there are things that some of you, if you've had an NSF grant from DOE, you've had to use these words, formative and summative in particular. Some of you may have heard of validity and reliability in terms of an instrument assessment. Item response theory is kind of one of the more snazzy, more modern item assessment theories than item difficulty and item discrimination, or more classic test theory. And then there's a whole bunch of just general statistics, things that people, once you have assessments, use. Okay, so we chose these based on focus groups. And then what we did is we just basically had this giant table, and we said, using these scales, so this is the scale. I've never heard of them. I heard, but I don't know what it is. I heard, and I'm not very confident. I heard, and I have a sense, or I'm completely familiar, right? So we allowed them a self-report. Oh, gosh, I'm doing survey research with self-report data. That sounds awful, okay? So we're going to talk about how we address the self-report thing. But that's basically what we're going to be talking about. The community saying, this is what I know about things, okay? We had IRB approval. They were assured of their anonymity and all those kinds of things. In order to be confident of the self-report nature of this, however, early on, remember the jargon table, as we call it, was the last thing in the survey, okay? Early on, long before they saw the jargon table, we asked them this question. Assessment of learning is a form of measurement, and it shares characteristics of measurement with laboratory experiments, because we're getting them into the things chemists think about. Thinking by analogy to measurement in a laboratory, which pairs are an accurate combination between a test measure and a laboratory measure? Check all that apply, right? So we built in an internal reference into our survey intentionally so that we could be sure that the self-report data on the familiarity with the assessment terms was mapping something reasonable. That is, if people said they were totally confident in their understanding of assessment terms and totally wrong on this question, there would be reason for concern about the self-report data, right? So we built in the internal reference with respect to this, okay? Having done that, we could look at the responses of this for this thing. So of our 1,546 in the sample, 9% or 6% of them left it blank. 29% simply got it wrong on all counts. The 25% was able to get either reliability or validity correct, and 40% got both correct. So we were able to stratify the sample, right, in an ordered way. So we could use ordered linear regression, which is what we did. Okay, I'm not going to go into the ordered logistic regression, not ordered linear, ordered logistic regression. Okay, but we can go through that process. We can calculate odds ratios, and here's the bottom line. The participants who get both of those things correct are twice as likely as all other participants to report familiarity with the terms, okay, across all kinds of different ways of looking at this. So the bottom line is that those who were actually right reported higher confidence. okay, or reported higher familiarity. So the internal reference works to help us feel confident about our understanding of the data in the jargon table, okay? Everybody's with me on that without going through, too much time here. Okay. Then we can get, this is data, right? So you say, student, go get me data, and they bring you this. Ugh, right? And you all hate that. Okay, so we don't want to look at data like that. What we want to do is try to break the data down into digestible chunks, and there's cool ways of doing that with respect to statistical methodologies these days. So structural equation modeling is one of them. So the basic idea is that we're going to try to model the variance of the data in terms that we believe are theoretically reasonable, okay, that explain why people answer the way they did about their familiarity, okay? And so the way that we did that, in structural equation modeling, this kind of map, the squares are actual measured values, the ovals are latent values that are built up in much the same way if you did factor analysis or any other kind of statistical methodology. And so latent variables are things that seem to control their answers to questions that you actually measure, okay? And we actually chose to use a hierarchical model. That is that if you were to ask the average faculty member, what do they know about assessment, they will just kind of give you some ideas about assessment. But if you push them a little bit, you could probably get them to go into differentiating program assessment versus item assessment versus instruments and assessment. So that's why we went with this hierarchical model. There are other models. We tried a lot, and I'm afraid I don't really have time to do that. But does this look awful as well, right? Why would we even want to think about that? There's way too much stuff there. And so the question is there a more parsimonious model that we can use to understand the structure of faculty knowledge about things like assessment? And the answer is yes. Okay, so I'm not going to go into all of our fit statistics, but this is actually our best model of all kinds, and this is in Press and J. Chem Ed. So the idea is that assessment, again, we have the overarching idea, and that faculty, in a broad sense, can clump their knowledge about assessment into program assessment. Did my grant work? Are my majors getting what they need to do? That's a program assessment level thing. They can clump that information. They understand that certain tests are good and not, maybe other tests aren't so good, right? So there is a distrust probably, for example, of self-report data, right, which I'm reporting on, all right? And that's legitimate. It's not the same as content test data, right? There's no question that there's differences there, and that's okay. But so there's a group like that, and then there's people who understand that there's such things as good test items and not so good test items, right? So a test item that doesn't have the correct answer available, for example, in the multiple choice is usually not a very good test item. And we try to avoid those in the Exams Institute, for example, although we don't always succeed. Every now and then weird things happen. Okay, so we have a structure for how, in general, the community of chemistry education understands assessment. But that doesn't necessarily help us target anybody yet either. All right, so we can take this a step further. Oh, okay, I'm sorry, I'm not even going to do that because I already told you that. We can take this a step further and actually look at the population and say which people fall into which categories in terms of how much they know about which things, right? We can do that using cluster analysis, all right? And when we do that, and there's lots of buried stuff under here with respect to cluster analysis as well, and I apologize for that, but we find an extremely good model that breaks up those 1,500 people into 6 clusters whose similarity is easily determined by looking at kind of what the response rates are on all of these various questions, okay? And that is there's a cluster that's highly familiar. They feel comfortable with pretty much all of assessment, and they answer highly on all of the items. There's a group, there's a kind of biggish group that's in the middle. They're kind of comfortable with some things and maybe not so much with others. And that group breaks itself down into stats being fairly high, or they're high with their familiarity with the general statistics, but maybe less so of the other parts of assessment. And then there's some who aren't very familiar with general statistics. And then finally there's the low with high familiarity statistics and low familiarity. Where would you predict? So, and then we can do this over all of our demographics. I'm only going to do one, because it's the one that's the best predictable. So how much time do I have? A little bit more. Good. That means I have time to do this, because this is the way I teach, and I hate that I just talked at you for this whole time. You've got 1 minute to explain to the person next to you where you think analytical chemists will fall more often than not in these groups. Talk about it to your neighbors. You got 1 minute. Seriously. Convince your neighbor. Okay, so I know that was a really fast minute. It was a New York minute, but we had to go with that. So anybody feel really comfortable that they say they have a place that they really think the analytical chemists are going to be overexpressed if we mix our metaphors and we talk about biochemistry and analytical chemistry at the same time? Where are analytical chemists overexpressed? High familiarity ones, exactly, right? It's certainly true there are analytical chemists everywhere in all of the clusters, but they are highly overexpressed in the places where the stats familiarity is high. Why? Because they use a lot of stats, right? So it's their science research is doing for them in terms of what they know about their education research, and that's a key idea, right? We need to leverage the bits that we can leverage from our colleagues, right? So that we can bring them in on our chemistry education innovations as we go forward. Okay, so what did you just endure, okay, since you gave me this time to do that? What I was trying to do is give you a little bit of a way that it's possible to look at ourselves in a quasi-anthropological way and get meaningful information about how to target the way that we can do education innovation and propagate it, right? That was what this was about. It also, at the same time, gave you a little bit of idea what it takes to kind of do the research, right? So you can see that we didn't just put out a survey and get a average ordinal data, which although we did put means up there, that was for a specific cause, and so forth. So that you think about how you do your statistics, and the methodologies for doing the statistics are really getting pretty easy to do, which means they can be dangerous, right? You put them in the hands of the wrong graduate student, and you'll get very interesting results. That's an important component to think about. And the other really important issue I want to note is that there's sampling issues here. We only had a 10% return rate, and we were overexpressing in our sample those who use ACS exams, not surprisingly, because they're probably more likely to open the email from the ACS Exams Institute than the rest of the population. And so more of them took our survey, so that's certainly part of our one issue we have here. But sampling is a really key thing, and that's one of the other things that we have a very hard time, and it's one of the problems we have in education reform. We almost always use convenience sampling, right? It's the students who show up, right? That's who we sample. And so we have to think, it makes it harder to, and therefore more important to try to think about how we replicate, right? So one of the key things, we had a collaboration amongst a number of us. Angie Stacy was talking later, was part of this group, where what we did is very consciously took instruments that worked in certain ways at Iowa State or at Purdue or at Berkeley and shared those instruments to see if they work in other environments, right? That's a really important component of making measurements in education, is seeking out the collaborations that allow you to replicate your stuff, okay? You have to be aggressive about that. There's also a bias issue, and I don't know for sure if this is a really big issue for MOOCs because their data samples are very, very large, but it's certainly something that you hear a lot of people when they talk about MOOCs talking about, and that is that we tend to make measurements, at least amongst the times we make measurements, is the end of the course when we've already thrown out the disaffected students, so they're not in our sample. And so there's a convenient sample with bias. It doesn't sound like the greatest combination, right? So we do have to think very carefully about some of those things. And finally, IRB, Institutional Review Board. This is human subjects kind of research. So if you haven't done human subjects research, this is an important thing, right? If we fundamentally know something is better to do for students, it's unethical to treat some of our students with something we know is not good, right? We can't do that experiment. So you have to design your experiments in ways that are appropriate for things. So that's another thing to be thinking about as you listen to all of these things that are coming afterwards. There's going to be lots of great ideas. Hopefully this sets up a bit of a framework for how we can think about taking some of these great ideas and building them into propagatable things. Propagatable, I guess. So lots of people have worked in my group over the last several years on all these things. Historically, I used to have a lot of money from NSF. No, NSF itself doesn't have any money, so it's hard for them to give any to us. But I appreciate the support I have had over the years and the great collaborators I've had over time. And my postdocs this year all got jobs, so that's why there's little arrows. And so I'm going to be down. I've got to go beat the bushes for more postdocs. So thank you.